So you might be wondering why we're having to jump through this hoop of a double jump between the visit and accept methods. Why can't we just make an overload and make sure that this overload works correctly? So let me show you what would be probably the most ideal case. We're going to get rid of iExpressionVisitor and everything that is related to it. So I'll get rid of the accept methods, and we're going to see how we can actually add that same functionality on the side with the appropriate dispatch happening. So I'm going to get rid of everything that we've done in the expression printer hierarchy, and we're going to do this again, but this time around we're going to do it differently. So first of all, I'll show you what it is that we want to achieve ultimately, because ultimately what we want is something like the following. We want an expression printer which has public void print addition expression AE and string builder string, come on, Visual Studio string builder SB, and we want a similar thing for the actual double expression. So we want the same thing for double expression. And then the question is, well, how do you implement addition expression? Because typically the way you do this is you say sb.append with the opening round bracket, and then you say something like print, and you say addition expression dot left, comma, SB. Left, comma, SB. There we go. Okay, as you can see, this doesn't work. The reason it doesn't work is because AE.left is of type expression, and we don't have a single overload which takes an expression. We only have concrete implementations like addition expression, double expression, and so on. And there is no way for us to persuade the runtime that all of these are going to be non-abstract. So we cannot do this. We cannot invoke this, but in actual fact we can through a hack. So let me finish off the implementation of both of these actually. So I'll put the implementation in here, and then of course for print we're going to have sb.append d.value, where this for some reason got called AE. It should be called D. There we go. Okay, so we want something like this, and the reason why it works, the reason why it will work, is because of this little trick I've made here. Notice that what I'm doing is I'm taking the left and right hand sides, and I am adding a dynamic cast. Now the implication of this is that whenever we actually perform this call, the call to print at runtime, what's going to happen is manifold. So first of all, the system will take AE.left and it will treat it as a dynamic object. Now remember, the whole dynamic thing is primarily done to support DLR languages which are weakly typed, which don't have a type. But in this case, it's going to be somewhat something of a reverse, because what it's going to do is it's going to try to call the print function where the type of AE.left, having been cast to dynamic, matches what AE.left actually is. And in this case, amazingly enough, it's going to find the correct overloads. It's going to call the correct print method. So let me just prove to you that it works. I'm going to say var, let's say var ep equals new xprinter, expression printer here, and let's make sb new string builder, and then of course we say ep.print, and here notice I cannot pass e and sb. That's not going to work either, because once again we have that same problem. It's weird that it's not being highlighted as an error though, and the reason is that it's an addition expression, so I guess that's okay because we have an overload for an addition expression. However, if I do it like this, then all of a sudden it becomes a problem once again. And once again, we can use dynamic dispatch by adding that dynamic cast to make sure that we're calling the right thing here. Okay, so having made this invocation, we can right line the string builder once again, and this will luckily actually do the right thing and print the right result to the command line. Okay, so what are the advantages and disadvantages of this? The advantage is we're not doing a double hop from accept to visit. We don't have any kind of visitor interface that we have to implement, and the classes are left untouched. So that's the upside. We can make a bunch of these overloads, and that's fine. But there are downsides. First of all, performance. Once you start working with dynamic types, you end up taking a massive performance penalty. And I have an entire product written using the dynamic visitor approach, and let me tell you, it does take quite a bit of time to resolve complicated trees when you cast everything to dynamic. It's quite simply not a good idea from the performance perspective. The second problem is if you are missing something, if you are missing, for example, a print overload, you're not going to know. So let me show you something. I can comment this out. I can build the project and everything builds. How is that possible? Well, it's possible because nobody's actually type checking these. They're being cast to dynamic, so they can be virtually anything, and nobody knows that there might be a double expression there that we're not processing because we don't have the right overload. And then, of course, the only way to find out is you execute this program, and you end up, predictably enough, with a runtime binary exception. And this runtime binary exception basically tells you, oh, well, I tried looking for the overload of print, and I didn't find any. Sorry about this. So this is problematic because it's going to blow up at runtime. And in my case, because I'm processing Excel spreadsheets in this approach, I do actually have it blow up from time to time because I'm exploring a very large hierarchy of types, and some of those types I haven't covered with the overload, so it just blows up in my face. Not very nice. The last problem, and hopefully should be obvious as well, is the problem of inheritance. Let's suppose you have double expression, and then from that you inherit and you have some super double expression or something. Well, the problem with this is that when you perform this dispatch, it's generally going to look for the type which kind of ignoring the whole inheritance hierarchy business. So it can get quite messy from this perspective as well. I suppose to a degree it's also valid for an ordinary visitor as well, but this whole thing of inheritance is also problematic, and you have to watch out for and take appropriate measures if you do encounter these types of situations. But this is an extra possibility that has been made possible by the dynamic language runtime, and you're welcome to use it on small examples, but if you're doing large scale stuff like I am, then you may end up with a massive performance hit, and you need to basically think about whether you're okay with it or not.